All right, we're going to take a quick look at 12.3b. This is linear correlation and lines of best fit, or remember, lines of pretty good fit. It says complete each problem and please note your answers may be different from those around you, and that's because they may be using different points. So one of the things we're going to do here is we're just going to talk some general principles or some general ideas when you're doing these problems, what things should you look for so that you can make it as easy as possible and still get a relatively accurate answer. It says use the results of an exercise program that are shown in the table and the graph below to answer the following questions. So the cool thing about this is we've got a graph and we've got the table with this stuff that's indicated right here. Now you'll notice that on this one it's got this point right here. It's got 0, 0. Neither of the axes are broken or anything like that. A couple of other things you ought to note is the scale on the axes are different. This is 10 for every box that we jump this way, and this is 25 for every box that we jump in the vertical direction. So you wouldn't want to count slope like this and say, okay, this is back 1 and then down 2. You definitely wouldn't want to do it that way. Okay, now let's talk about drawing a line on this one. We could draw lots of different lines. So let me show you one line that might work. One line that might work is to just go from here and maybe go right through there. You'll notice that it's a little bit above the last one, and there are 4 lines that are above that. That's not too bad. That's not the end of the world, but it does use 2 of the points on here, and this y-intercept right here, which is what it is because it's where it crosses the y-axis, this point here is 0, 0. So that gives you a huge advantage. You already know what the y-intercept is. Now, to my eye, that looks a little bit funny as far as the line goes, but it does make sense as far as the situation goes. The number of minutes and the number of calories. So if you exercise for 0 minutes, you're not going to burn any calories. That's actually a really good point to use. But if somebody else came along and they said, you know what, I don't want to use those points. I want to use these points right here. I'm going to use that one and that one. So this one right here and this one right here. Now you'll notice that it kind of goes through this point right here, almost through that one. We've got one point that's above, one point that's below, and then we've got this one over here. So those 2 points would be totally okay. So we've got an example where we use this line right here, which looked pretty good here. We've got 4 points above and 1 point below, not too bad. And then we've got this other one that kind of balances those. I kind of like the red one here, but if you do have a point where you've got a y-intercept and that's given to you, I probably would go ahead and use it because that's going to make a lot more sense, and it's also going to make the problem easier. So even though that one to my eye looks a little bit better as far as the data set goes, we're actually going to use this one. So let's draw our line just like this, and let's use these two. And then you can go through and you can answer all of the questions down here. You can find the line of best fit. You can pick those 2 points, calculate the slope and all of that sort of stuff. And then you can also interpret what that means in the context of the situation. You'll notice that we've got a similar deal here. We do have a y-intercept. We have a broken axis here, so make sure you pay attention to that. If you're going to draw this, probably not a good idea to go from the first one to the last one. Maybe something like this would be a good idea. That would be a good balance. These two or those 4 are pretty close to the line. This one is pretty far off, but it's only one of them, so that wouldn't be too bad. I do want to take a quick look at this one right here. It says, so this is starting with problem number 13. Here's the situation. The results of a comparison of fat grams to total calories in fast food that are shown in the table and graph below. We're going to use those to answer the questions. So let's take a look here. We've got this information there. We've got the data to represent these points right here. Let's look at these and figure out how we're going to use this. Well, I think it would be a good idea to use this point, and maybe let's see what it looks like if we have it go through these points right here. Okay, now to my eye, I think that looks pretty good. So I'm going to go ahead and kind of double this up right here, extend it like this. Now we could not say that this crosses it exactly, gosh, what's this counting by? Counting by 25 for each line at 175. Maybe it's 175, but we're not quite sure. But we can say this. We've got this point right here and we've got this point right here. Let's go find what they are. This one looks like it's about 9. Do we have one there? Yep, 9 and 260. So this is 9 comma 260. And then the other one over here looks like it is, so it's this one right here, not the one at the very end or the second one. This is 30 and 450. Do we have a 30 and a 450? Not a 30 and 450, but 452, which looks pretty good. So this is 30 comma 452. All right, so we've drawn a line of best fit. Now we have to calculate the slope. So we're going to do y2 minus y1 over x2 minus x1. So that is going to be, we're using this point right here and this point right here. So we're doing 452 minus 260, and we're doing 30 minus 9. So 452 minus 260. Let's grab a calculator and get both of those. So I've got both of those on the calculator. 452 minus 260, not surprisingly, it's close to 200. So 192 here, and the 30 minus the 9 would be 21. Now, this is what it would be. Maybe we can reduce that, maybe we can't, I don't know. If we can, I think 3 goes into both of these, but this is a story problem anyway. So let's just change this into a decimal. So let's on our calculator grab this, and we'll do 192 divided by 21, and we end up with 9.142. So let's go to the nearest hundredth, 9.14. So 9.14. All right, so we've calculated the slope. There's our answer. Now the next part says, what does this mean in the context of the situation? What does that mean in the context of the situation? So this is 9.14 over 1. Let's think of it as a rate. Let's think of it as a fraction. And remember what goes on the top. This was calories, and over here was fat grams. So this is total calories, and this is fat grams. So what does this mean? If we've got 9.14 total calories for every 1 gram of fat in the food at these fast food restaurants, we just kind of have to say that. There are 9.14 total calories for each 1 gram of fat in this fast food. And that gives you a good way to kind of make decisions about, gosh, I could just look at the number of fat grams, and that gives you a good way to kind of make judgments about what you're going to eat at fast food places. So if you can reduce the fat grams that you take in, you're going to be reducing a lot of the calories that you take in. So that's just kind of a quick look at a couple of these problems, how you might approach those. There are more parts to these problems, so you want to finish this up. If you've got questions to ask, this is a really good investigation. These are real world situations, and lots of times there are these correlations, and we can come up with a line to start making predictions. Good luck on the assignment.